Thank you.
Okay. Thanks a lot for the introduction. And because my student Wang Peng have a visa problem, so I'm Biao Xiong from Wuhan University of Technology. I'm from the School of Artificial Intelligence, and my work is more on the use to do the 3D and 2D understanding and reasoning. And in this work, we use a large language model for the precise room level geometric reasoning for the indoor floor plan generation.
Sorry, I need to use
this one. Okay, so that you see nowadays we use a lot of generative AI, especially for the large language model, and we know it's very powerful. And but we have a saying that because large language model is a kind of it's good at natural language, but is it possible to do the geometric and numeric numbers reasoning? So that we try this also for the floor plan and the indoor design. So we in this research we try to understand and reason that is it possible. So that we also know that it's a very important issue that for the indoor design. So that also because of the time limit, so I won't go very detailed to the previous work, that because there are also a lot of work like on the high top AI or computer vision conference. So there are also some works. But most of this work that they assume a room is a kind of a rectangle, and also they can say that they use a lot of input that they say they need that how many rooms and what kind of rooms they need, and also they want to know the addressing. That the bedroom should be neighbor to the living room, some kind of this a lot of assumption and input. So here that we make it much simpler is that we only give input. Here we have a very complex outer exterior of this house, and we say with this as a constraint, and we only we want a 3-bedroom and 1 living room and 1 bedroom, and with this kind of input, and can you make a good design for me? So that we also based on this that we use a kind of large language model, and I will show you later. So that this is output, and this is we have an input, and we also this is the result, and we say we use a kind of like a JSON. Explain this like JSON for each room, that for each polygon we use a kind of a natural language. We use this kind of position. It's just raw TXT file, and so that all these polygons as well as the inner polygon and the exterior polygon, and we put this as a kind of promote. So for the promote that we say this is the exterior polygon, and we say we want 1 kitchen and 1 living room and 2 bedroom, and this is the answer. So that for each for each living room, we will give the polygon. So we combine this kind of training material, and we also say maybe there are some other ways that use this is for JSON TXT, and this is the plant TXT. We'll try okay which one would be better. So here that we have this kind of data set. So this is like for the prompt. And we use to train a kind of large language model. Here I will explain later. Here we use this kind of queen, and so by this kind of training, and so we use a kind of like 10,000 of this kind of training data set. And after the training, then we will use this prompt, and this large language model, we can predict the very detailed and accurate the indoor planning. So here is the result. Okay, we will say that I give the large language model with an external boundary. So this is the boundary, and I will say that one kitchen and one two-bedroom, one living room, and one bedroom, and one balcony, and then it will just predict this kind of polygons. So this is the result. Here are more results like here. So that this is like for every law that is input with out exterior polygon, and this is the ground truth. This is for the training, and here that we can predict different types. So you can see that it will have maybe can predict several types that for the users can choose. So you can see that the result is quite good and reasonable, and it's also diverse. It may have different type, like for this is the kitchen. This kitchen may be in here, or maybe here, or maybe there. So here are some results that compare to other the methods that there are. It's very detailed and very good designed models to make this design, and we just use to fine-tune the large language model. It's here for the Queen, and it's 8 billion model. It's actually quite small, and we use the JSON. Here is the result. We can see the time, because we all know that for the large language model, it's a bit time expensive. But for this, its FID, it means that how similar to the result to compare to the ground truth. And here is for the type, because different room types and this agency, and especially for this kind of gap, because we estimate different room. Is this kind of room have the overlap, or maybe it's that it will be outside of the exterior polygon? It's actually, you will see this is quite low. So we can see that use this large language model, we can have very good and accurate geometry reasoning. So here we have some ablation study, because we will say, okay, is it possible that we use different large language model? Here we compare that a Queen and a Llama, and we also have tested some others, but we didn't show here. And so for this one, that we can see that actually the large language model, which one you choose, actually it doesn't matter too much. And as well, because we also compare with different parameters. Here is 1.7 billion parameters and 8 million parameters. We will see that if we get more parameters, of course, it will get a better result. But the time will be, the training and inference time will be more expensive. So usually we will say, okay, for the 1.7 billion parameters would be enough, because actually for our task, is actually for the large language model, it's a small task. So we think this is okay. And we also test that which kind of the text, like use JSON or plain TXT, which one is better? We will say usually that plain TXT would be worse, but it's very similar. And because JSON is more easier to understand, so we will prefer to say we use JSON. And because it's have more text, so it will be more expensive. And here is we will go in the previous one. We just to divide the different rooms, and here we will go to more details of the furnitures. So it's a very similar way. So we also train like this, that so for each furniture we will use that it's a bounding box, the width, the size, and the position, and as well as its orientation. So we will see that for we have this each room. For each room, it have a polygon boundary. It's all presented in the XY position. And for each object, we have types, like it's a chair, and the parameters. The parameters would be the center, XY, and the width, and the length, and the orientation, the angle. So this is 5 parameters. So we will also use a kind of self-fine-tune training, and then maybe this would have some problem. So we will have a kind of a reinforcement training. We use GRPO training. There are many other training reinforcement training strategy, but we tested that this one is the best. So here.
Can conclude phase.
Okay, I will go very quickly. It's because here is a result. So we will see here is more the result that we visualize is in 3D. And here are some results that you can see it's quite reasonable. And here is more that we combine. First, we do the room plan, and then for each room we make the furniture plan so that we give an input of the exterior polygon. Then this model can make a good and reasonable the design. So that we test the conclusion that we say the large language model could do a good geometry reasoning, and the second one that we should take care of the training data set very well, and as well as the training strategy. So thanks a lot.
Thank you.